to the CHP unit. Yeah, so it's protecting downstream valve fittings, etc. of our gas supply system. That's an overview. So we have the gas blower goes here into the filter, the twin double solenoid valve meter, Forex flow meter. Then we have a pressure sensor, temperature sensor, measure that we can measure, for example, H2S with the Träger measurement tubes, or ammoniac as well. Then we have the gas actuator. In your case, the gas actuator works fixed on one position. If the engine starts, it's open to the target position. If the engine stops, it goes back to 0 position. Then we have a flame arrestor, and then we connect to the mixture where we mix the gas to the air. Yeah, so let's go quick again. We now talking about here this gas solenoid valve. Yeah, so we are talking about the twin gas solenoid valve. So the twin gas solenoid valve looks like that here. We can get it in different size, depends on the engine gas supply size. So the solenoid valve operates automatically and open if the engine or the CHP start and operate in gas mode only. In case of a gas alarm, so we have gas sensors in the room for methane gas, the arrow will immediately stop the CHP and close immediately the valve to prevent that we have any gas flow into the machine room. As well, the function of a gas alarm in the machine house means that that the CHP start or still operate the ventilation system to get the air out of the system, out of the machine house. Okay, after the CHP stop, the valve will close. Yeah, and in light oil mode operation, like diesel operation, pure diesel operation, the valve stay closed continuously. So the valve is only open in gas mode. So for the solenoid valve, there is a special check system or control system that check the valve of tightness before the system or the CHP start in gas mode. This unit here is connected directly to the solenoid valve. What test the tightness between the twin valves in between, that there's no leakage or tightness between the valves before the start. So only to ensure that the solenoid valve is working properly, there is this control system. In case that we have a leakage or something not working on the valve, so we get an error message to the visualization which will stop or not allow to start the CHP in gas mode. From the gas filter and solenoid valve, we coming now to the gas meter. So Schnell used in the standard application always the gas vortex flow meter. So the gas vortex meter measure the quantity of the gas flow through the pipe to the CHP. The meter, there are different designs of the meter. Usually the meter has a temperature sensor inside, sometimes absolute pressure inside or external as well. The temperature and the gas pressure is needed to calculate norm cubic meter measurements. So the norm cubic meter measurement at the end of the day means we have a temperature and a pressure compensation on the gas flow. The norm is on 0 degrees Celsius and 1013 millibar pressure, so sea level. That's the norm where the gas get compensate, so calculate to compensate. That's very important to compare systems with systems, because if you have different temperature in the gas or different pressure, your volume will change and you cannot compare system with system. And all the efficiency calculations always based on a compensation norm cubic meter per hour. So that's why it's very important to understand it's always a calculation on temperature. So they measure the temperature and compensate it to 0 degrees. They measure the pressure and compensate it to 1013 millibar. Yeah, so we have here the flow meter. Now we're going to the next part on top. There's the flame arrestor. So the flame arrestor is a mechanical part. It's actually a safety part to prevent ignition of a gas with backfire or back ignition from the gas mixture of the combustion chamber or from the engine into the gas system. So this is the arrestor is built with a very fine mesh of special steel combinations where the gas runs through. If you have a back ignition on the side of the engine and you ignite the gas because you have enough oxygen inside to ignite the gas, and the fire like to go back through the arrestor start to clog up and close, or not close there, to kill the fire. So the fire will not go into the gas pipe. But the arrestor can get clogged. If the gas filter is not replaced properly, or we get condensate, or as well if you get too much sulfur content in the gas, you can get some humidity, sulfur content, and then it start to block this fine mesh of part of the arrestor inside, and then it can get clogged. That means at the end of the day you will not get any gas into the engine. So we have to look on the gas filter and always make sure that we're not getting any dirt, condensate, water, and as well not a too high H2S content, so sulfur content into the gas train supply system. Okay, so now we're coming to the gas regulator or activator valve. This one is in your case, it looks like that. That's the valve, that's the motor. So the regulator valve opens from 0 to 90%. Actually, I'm thinking it's 0 to 90 degrees. So the activator valve can be adjusted about the power settings. Usually in your case, the power load control is via gas blower. There is an opportunity to use the gas actuator as the load control, but it's not standard. If you have only one centralized gas supply blower and no separate gas blower at each engine, then the adjustment will be to control load on the gas actuator valve. If you have on each engine one gas blower, then the control of load will be on the gas blower. In your case, I think it's all on the gas blower side. So that means the gas blower, the gas actuator valve is a valve in the supply pipe. What the motor is connected with a shaft to the valve inside of this aluminum block. So this motor is the actuator motor. We have here red rings and yellow rings. So the rings are the bottom red and the top yellow rings are the end switch of the position, of the maximum position, so the minimum and the maximum position of the motor. So the red ring must be adjusted on 10 degrees and the yellow one must be adjusted on 90 degrees. So that means I give them with this rings and the switch the maximum position between close and opening of the valve. The control will be taken over from the PLC. So I can adjust on the PLC how far or how wide the motor should open. But the rings are limiting the mechanic system of how far it closes and how far it can open. Here we can see the valve. It's like a cylinder inside with a special weird characteristic to give them a linear opening structure. If they open the cylinder, it's give a linear opening structure. Important is to pay attention of the installation, that the gas flow comes from the left, goes to the right. There's an arrow on the aluminum block which shows which direction must be mounted. The system have usually here flanges. The flanges would get mounted with screws and seal where the flanges are then connected to the pipe. So there is important that we make sure that there is no leakage, and as well again we need a clean gas. This valve is sensitive of moisture content of small particulars what you get into the system, because it's like a cylinder working in the aluminum block, and over time with dirt and condensate or water or H2S or sulfur particles, it can start to damage the cylinder what is here inside. Let's jump in now into the charge air cooler system. We have here in the flow, if the gas supply comes in with the air, and then we're going through the turbocharger into the charge air cooler system. The charge air cooler system, so the charge air cooler is sitting in front of the CHP. So the charge air intercooler system is operating with two stages of water side. We have here stage 1, what is connected is these pipes directly to the engine coolant. So the first step from the hot charge air what comes through after the turbocharger, what get heated up very hot, get cooled in the first stage from the engine water. The second one, it's that part, it's connected with a separate external radiator cooler. Here on the left hand side we have the inlet. We have the inlet from the turbocharger. The gas air flow is from the left to the right hand side and get out to the inlet manifold to the engine. Okay, so as I mentioned already, the charge air or the gas-air mixture get very hot. So the increasing of the charge air pressure from the turbocharger here. So we increasing the pressure. That means through the increasing, we will increase the temperature of the charge air as well. And the function of the charge air cooler or intercooler is to cool down the gas-air mixture and keep it on temperature target. The standard charge air temperature target is 40 degrees. Okay, in special application we work with a higher charge air temperature, and that must be decided from case to case. The second stage of charge air is that part of the charge air cooler. That part is connected to a separate cooling system, cooling cycle. So the first stage here is connected to the engine coolant to cool down as much as it can with the coolant water, so with the cool water of the engine. The second one is with a separate cycle, what is connected then to the control system and the safety module to keep the temperature stable before it's reached in the engine. And the control will take over from an external radiator cooler and from a free wave analog controlled valve. So this is the safety module with a pump and the free wave valve, and we have the radiator cooler. So the standard function is the following. After start, the radiator cooler fan, we're talking about that one, will start and operate on minimum speed. So the fan will operate on minimum speed after start. The free wave valve, it's here number 2. The free wave valve will control the coolant water flow through the charge air to keep the temperature on target. So if the free wave valve reach the full opening position, so that circulation reach the full opening position, so we're running then 100% through the radiator cooler elements. The second control on top is the fan of the radiator cooler will start to increase the speed to have more cooling energy for the charger. The radiator cooler fan is speed controlled by a frequency converter, and the frequency converter, as all other frequency converters, are connected usual with a CAN bus system with the PLC of the CHP. So the CHP can control first the free wave valve position to cool down and keep the temperature of charger stable. If this reaches the full opening, the fan of the radiator cooler will increase speed to cool down the rest of the charge air. So we have here the 6R20 charge air cooler system safety module. The flow rate through the cooling system, what is connected to the charge air cooler, to the charge air cooler, and connected to the radiator cooler, operates with a flow rate of 70 liters per minute. So that pump, the green Wheelo pump here, and the system here must be adjusted that we have a flow rate of 70 liters per minute. We'll come into more details when we talk about the whole cooling system. The filling water pressure of this external system is, if the water is cold, we're talking about 2 bar filling pressure. If the water is warm, we're talking about 2.5 bar filling pressure. The expansion tank filling pressure on the gas side of the expansion tank is adjusted to 1.5 bar on the gas side. That's very important to adjust. Okay, now we are talking about the air temperature control for the engine air. We have here the air supply system to the air filter. The control of air temperature to the air filter and engine will be adjusted with a flap inside of this T. The option or the control of the system make the advantage that we can control the temperature to the air filter and keep it stable. We can mix the air flow between room air and outside air. So we get here the outside air in and here the connection to the room air or machine house air. So in winter time, if the outside temperature is very cold, we suck more air from the inside room to get or keep the temperature stable on a target of 30 degrees. If in summer the temperature in the machine house is very high, we open more the valve that we suck more air, fresh air from the outside to keep the temperature here. Here's the temperature sensor, stable on the target of 30 degrees. This will be made through the motor here, what is mounted at the pipe to keep the temperature stable. So now let's move to the exhaust gas. I see it's the video getting a little bit longer than I assumed. But anyway, let's go through it. Okay, our exhaust gas system, we can see it here. It's in brown. Number one, let me move on the other side. Number one, here we have the exhaust gas pipe. So the standpipe what goes into the outside. We have number two. We have here inside silencer. Usually it's installed inside of the machine house or the container. Number three, we have here in that area there is connected the NOx exhaust gas sensor, which measure the exhaust gas content, where we do control about the ejector angle. Number four, we're talking about the turbocharger here. Number five, it's the turbo compound. It's placed underneath here. From the turbocharger goes to the turbo compound. From the turbo compound goes to the NOx sensor. From the NOx sensor goes to the silencer for the first silence. Number six, we have here the outside silencer standing behind the machine house. Number seven, we have a second measurement socket to measure exhaust gas with the external tool. The first one is here next to the NOx sensor, and the second one is outside. So we can measure the back pressure, the exhaust gas values